Good morning, guys. Today we get to start chapter 9, and we have a few lessons in here, and so we're just going to get to it. So the first one is 9.1.1, which is on multiple representations of functions. And so basically, we've gone through a lot of these. It's that you've got a graph, a table, an equation, and you can use all of that to all represent a function. So this one starts with like where you match a graph to a situation. So if the price of a shirt holds steady and then a celebrity wears it, and so the demand increases, so they can increase the price rapidly, and then it holds steady again. So that's what that could be. This could also be someone driving at a steady speed and then increasing their speed and then at a steady speed again, but faster. So maybe they got on the highway. So they were on the side road and they increased as they were on the on-ramp, and then now they're on the highway, so they're going faster. So those are just graphs that represent a situation. Some people call them situational graphs. There we go. And that's pretty much that entire section. It's pretty simple section, so I'm not going to spend too much time on it. Okay, so the next one is 9.1.2, and this is about something called piecewise functions. So piecewise functions, some people call them step functions, but basically it is when you have, I'm going to go ahead and do a whole graph, like multiple functions on a coordinate plane for just different sections of time. Okay, so you might have, a lot of times you'll see, well, the ones in the example are like this, where it's like all steps in a line, but I want to show you some that are a little bit different. So you might have like from here to here a line, and then it might be a quadratic for the rest of the time. So it's part of one function and part of another. And the thing that you separate them by their domain, by their x value. So let's say this is -7 and this is -3. So this function, I'm not sure what it is, but whatever it is, some linear function would be from -7 to -3. And then this other function would be from -3 to infinity. So does that make sense? So it's these in a sense go on forever, right? But we're saying, hey, we only want to see this piece of the function from here to here, and then we only want to see this one from here to infinity and beyond. So a lot of the ones you're going to see in the homework are like this. You know, like lines like that. And let's take a minute. Why is this dot closed and this dot open? Why can they both not be closed dots? So talk with a neighbor. Why can they both not be closed dots? You might even need to pause the video. Make sure. I'm not going to tell until y'all have all decided. Why can they both not be closed dots? It is because then it would no longer be a function, because I cannot have two y values for the same x, so x can't repeat. So one of these has to be part of the function and one of them can't be part of the function, because I can't have two of the same x values, so it wouldn't be a function. So let me show you how these are graphed. Okay, I mean how these are written. This is number 6 from your homework. So g of x equals -2x plus 8 when x is, and this says if x is greater than or equal to 4, and 1/2 x if x is, I'm sorry, less than or equal to 4. This one is if it's greater than 4. So to graph this, okay, so the first line is -2 x plus 8. So if I go 1, 2, 3, 4, 7, 8, and -2 means I'm going to go down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. Okay, so here's this line. Okay, but I only want this line when x is less than 4. Okay, so I actually need to 1, 2, 3, 4. Okay, so from here and on is this line. Okay, so it includes this point. Now, for the next one, 1/2 x. Okay, so 1/2 x means up 1 over 2. Up 1 over 2. Up 1 over 2. So starting right here, I'm going to have this line. So this one is here. This one is here. Does that make sense? And now in theory, this line does go on forever and this line does go on forever, but in a piecewise function, you're saying, I want this function, but with this restriction. Or I want this function with this restriction. So that together, it still makes a function. Because see how these don't overlap? There's still only one. When x is 4, y is, whatever that is, 16. Not 2, because this is not part of the function. Okay, so here's what I want you to do right now. I want you to pause this video. I want y'all to use your calculators and your phones, and I want you to look up Google how to graph a piecewise function in your graphing calculator. Okay, so how to graph, well, I'm not going to write it all because y'all know how to write into Google. How to graph a piecewise function in a TI-84. Okay, and then I want y'all to all figure that out before you continue. Okay, so I want you to be able to graph these in your calculator before you move on. So pause right now, pause video now, and do that, and then come back only once everyone has done it. Okay, try some, look some up, try some. Okay, next lesson is 9.1.3, and it's on transforming functions. Now, we have done this a lot already in a variety of functions in a variety of ways. There is some kind of new vocabulary where we talk about like compression, horizontal compression. Translation is moving left and right. Compression is the same as dilation. So it's horizontal compression makes it closer to the x-axis. Vertical compression makes it closer to the y-axis. So like if I have a function that's x minus 6 and I say translate up 7, the new function would be x plus 7. Does that make sense? If I have a function that is, let's see, 3x, and I say compress by a factor of 1/3, well, 1/3 times 3 would just be x. So then it would just be y equals x. And multiply. Remember, when you're doing any kind of compression, you're multiplying. Translating, you're adding and subtracting. So this is not a very long section. You're just taking different functions, reflecting them, moving them up and down, that kind of thing. So there's only, it's not a very long chapter. So I'll leave you to finish that one. Okay, the last one is operations. This is 9.1. No, that's a lie. 9.2.1. Operations with functions. Okay, so what are the basic operations in math? With functions. Okay, so what are the basic operations? The basic operations are add, subtract, multiply, and divide. So we're going to do those operations, but with functions. So if I have f of x equals, let's see, 2x plus 5, and g of x equals 3x minus 4. Okay, if I add those together, I can say f plus g of x. Okay, which means I'm going to take f of x and I'm going to add it to g of x. So then I would get 5x plus 1. Okay, I can also subtract them. Let's subtract g minus f. So g minus f of x. So it would be 3x minus 4 minus the entire function 2x plus 5. This one has a trick. What am I going to do with this negative sign? Does it go to the 2x or the 5 or both? That's it, both. So then I have x minus 9. Okay, so that's the easy one. Adding and subtracting is the easy one. And you just combine like terms. Combine like terms. So you're given two functions, like a definition of two functions, and you can add them or subtract them. So what do you think is next? Once you multiply them and divide them. So f of x equals 2x minus 3, g of x equals 6x plus 4. So if I multiply them, it's basically just binomial, two binomials, dub distrib, right? So you would get 12x squared plus 8 minus 9, so minus 16 plus 8x minus 18x. Sorry, I'm struggling with the math this morning. 12x minus 10x minus 12. Okay, so that would be multiplying. And then dividing. In this case, there's nothing I can do to divide them because there's nothing I can factor and cancel, so that would just be the answer. Sometimes you might be able to factor and cancel something. I think some of the practice problems you can factor and cancel things. Okay, last one is, it's called composition. Well, first we're going to evaluate and then we'll do some composition. Okay, so if I have if I have, here's two functions, and I say evaluate g for -2. Okay, so what does that mean? Well, instead of x, I'm going to replace x with -2 because I replaced it right here. So 4 times -2 squared. Well, -2 squared is 4 times 4 is 16. So this tells me a few things. This tells me that when I put -2 in for x, I will get out 16. So that's the ordered pair for this function. If I put in -2, I get out 16. So I can write it like this. -2, g of -2 equals 16. So that's called evaluating a function. And you can put anything in to evaluate the function. Like I could say h of 100. Well, that's 100 plus 2, which is 102. Okay? Now, when we do something called composition of functions, we put, instead of putting a number to evaluate, we put a whole function in there. So for composition, I'm going to say, what is g of h of x? So I'm replacing the x not with a number, but with another function. So 4, and instead of x, I'm replacing it with h of x, which is x plus 2 squared. So 4, and then this is x plus 2 times x plus 2. So that's x squared plus 4x plus 4. Then distribute the 4. 4x squared plus 16x plus 16. Okay, so I'm putting one function inside of another function. So I can do the reverse of that, or the opposite. I'm not using either of those words actually correctly mathematically, but I put h inside of g. Now let's put g inside of h. So h of g of x. So in this case, I'm going to start with h of x, and I'm going to replace this x with the function g. Now in that case, that's simplified as it goes, because there's nothing else I can do. So you're putting one function inside of another function. So we're going to do another example. So f of x equals 3x minus 9. G of x equals x squared plus 2. Okay, so let's do f of g of x. So I'm going to start with f, and where there's an x, I'm going to replace it with g of x. Okay, so I took this function, and where there was an x, I replaced that with g of x. So then that's 3x squared plus 6 minus 9, which is 3x squared minus 3. Okay. Then let's do the opposite. So g of f of x. So let's see. I'm going to start with g, and instead of x squared, I'm going to replace the x with 3x minus 9 squared plus 2. So then this is 3x minus 9 times 3x minus 9. So then that's 9x squared minus 54x plus 81 plus 2. 9x squared minus 54x plus 83. Okay, so we're taking one function and putting it inside of another function. Now, we can do this with even 3 functions. So if I have g of x equals 2x plus 1, f of x equals x squared, h of x equals x plus 9. So I could do a couple of things. I can do g of f of h of 4. So that means I would put 4 in here. So if I put 4 in here, what do I get out? 13. So then I'd put 13 in here. 13 squared is 169. Then I put 169 in here. 169 times 2 is 338 plus 1 is 339. So then this would be 339. So I did that kind of fast, so I want you to go through and make sure we understand that. Then I want you to do 2 more problems. G of f of h of negative 2. So I want everyone to figure that out. And then I want you to do f of g of h of x. So you're going to put h inside of g, then g inside of f. And this is the composition of functions. So you're going to end up with a function. This one you'll end up with a number. This one you end up with a function. So I'm going to leave y'all with those. I want you to do them until y'all all agree on answers. And then Ms. Clark, you can put up some questions from their subchapter and let them get started on subchapter questions, especially these composition ones. So hope you have a great day, guys, and I will see you next week in class, live, in person. Don't miss it. Be there, be square. Bye.